Hi everyone. In the last video, I have shown you how to compute limits, derivatives, and integrals using Maxima software. Today, I would like to show you how to solve ordinary differential equations, uh, which can be very useful when preparing our classes or solving problems in physics. So let's start in 15 seconds. Then in the last video, I have shown you that Maxima knows how to derivate, and we can compute the derivative of a function with this command diff. If Maxima doesn't know the function, it's going to give us this result. But if the function is known, then it returns us the result. So with this now we can construct ordinary differential equations, and we can solve them using Maxima. For example, I'm going to construct a first order differential equation as an example. Just a note, we have to put a prime before diff so that Maxima does not compute it when we are defining our differential equation. So in this case, the function of the equation is y, and the variable is x, and the equation has this form. So Maxima puts the equation in a way we can read it. And to solve this equation, there is a command that is ODE2. And this command accepts the differential equation as the first entry, the function that we want to find, and the variable of the equation. And it returns the solution. Since we have not told to Maxima what is the initial condition, the solution comes in this case with one arbitrary constant that we need to find. In order to find this constant, we need to tell Maxima what the initial condition is. In this case, the initial condition, for example, I will use that y when x is 0.5 is 1. How I tell Maxima that this is the initial condition? I tell it with the command IC1, since this is a first order problem. Then I put here the solution, the general solution, where the constant is not yet defined. And I put the value of x of my variable. In this case, we want it to be 0.5, and when x is 0.5, y is 1. Then Maxima returns this specific solution with this initial condition. And with this, we can, for example, construct a function so that we can compute values of this function. And in order to do so, we are going to use define, and let me say that the function is f of x, and This is this specific solution that I have called S underline so. So I just want the right hand side of this equation. So I'm going to put here just of S underline so. And then I can determine my function with this specific initial condition. So let's try now a second order equation. In this case, I'm going to use the example of the simple harmonic motion. The equation in this case is this. The second derivative of x with respect to t plus k times x over m, this is 0. So this is my equation. And again, to solve it, I'm going to use this ODE2 command. Let me call this solution so. ODE2, I have to tell what equation I want to solve, what is the function, and what is the variable. And then, in this case, since k and m are not defined, it asks me if k times m is positive, negative, or 0. In this case, we want this to be positive, and then shift plus enter, and then Maxima returns the general solution with now two arbitrary constants. In order to find these arbitrary constants, we need to tell Maxima what the initial condition is. Let's say that now that the initial condition in this case is when t is 0, x is 0.1, and the initial velocity is 0. So the specific solution is going to be now. Now we have to use the IC2, since this is a second order problem. We have to tell to IC2 what is the general solution. I called it so. We have to tell what the value of t, what the value of x when t equals 0, and now we have also to tell the value of the derivative of x when t is 0. In this case, this is the velocity. So diff of x with respect to t is going to be 0 in this case. Oops, something's wrong. Sorry, I forgot the prime here before diff. And now it gives me the solution. This is what I wanted to show you today. I hope you think solving ordinary differential equations with Maxima can be very useful, not only on preparing your classes, but if you do research solving ordinary differential equations, then Maxima can be very useful too. So see you in the next video.